I've known rivers. I've known rivers ancient as the world and older than the flow of human blood in human veins. My soul has grown deep like the rivers. I've known rivers, ancient, dusky rivers. In southern Africa, due to the negative effects of climate change, population increases, rising poverty levels, and water insecurity in the region, there is an urgent need to monitor and secure water resources for the population. Owing to the mobility of water, establishing real ownership makes it impossible to establish concrete boundaries over the streams and rivers of the region. In these cases, water managers in different countries need to work together to conserve and monitor the sharing of this precious commodity. There are 16 river basins in the SADC territories, covering over 90% of the water resources in the region. The revised SADC Protocol on Shared Watercourses provides the basis on which the countries sharing these basins can cooperate for their mutual benefit. The Orange Senqu River Commission, ORASECOM, was established under the revised SADC Protocol and was one of the first shared watercourse institutions to be formed under the revised protocol.
The goals of the Orange Senqu River Commission are to promote transboundary water cooperation between the states of Botswana, Lesotho, Namibia, and South Africa. And what that really means in terms of actions is that the nations are working together jointly to plan for future developments and to manage the water resources that exist within the river system, very mindful of the economic importance of the Orange Senqu River, but at the same time also being conscious of the importance of conserving the river system ecologically and as well as for livelihoods of communities.
During September to November 2010, the first joint Orange Senqu River Water Resources Quality Basin Survey, or JBS-1, was conducted. The purpose of JBS-1 was twofold, in that it was intended to undertake the first baseline monitoring of aquatic ecosystem health in the Orange Senqu River system, against which ORASECOM could monitor impacts of any basin-wide measures taken through the future 5-yearly intensive monitoring programs. Secondly, it was used to define appropriate sampling sites based on site visits and local knowledge that could be used in future surveys. In 2015, the second intensive monitoring program, JBS-2, got underway. Ground Truth, Water, Wetlands and Environmental Engineering were appointed as the consultants to conduct the second of 5 yearly intensive monitoring programs.
The logistics for this particular project are very complicated because you've got multiple different aspects to cover. What we've obviously had to do is sort out the route was the first place to start and really try and figure out what would be the most efficient way of traveling between the sites. We've had to organize all the equipment for the teams, make sure that we are using the same equipment.
The primary focus of JBS-2 is to successfully implement the required aquatic ecosystem health, chemical, and microbiological sampling in a similar manner to that of JBS-1. This second joint basin survey continues the spirit of cooperation among the 4 countries under whose care and well-being the basin falls.
South Africa is one of the 4 partners, so we've got an equal share together with the other countries. We are providing support in the sense that where we do sampling in South Africa, we lead the teams, we make sure that we have access and right of way where we need to get into properties. We also know the river in South Africa, so that know-how is provided then by South Africa as well. Obviously, some of our laboratories also take part in the analysis.
The government of Namibia contributes through supporting its staff by taking part in the survey during the sampling process and during the public event, and also during the laboratory benchmarking exercise. The laboratory is analyzing the samples on its own cost.
The government of Lesotho is highly dependent on the river system being conserved. As you might know, one of the major revenue earners for the government of Lesotho is water, through the royalties that we receive from the Highlands Water Project, which is part of the Orange-Senqu River Basin. And therefore, we have a very keen support or responsibility in the conservation of the Orange-Senqu Basin.
We have our people from Botswana participating. We provide the overall support from the different structures that we have in the government. By virtue of us being part of the team in terms of the water quality team that has been established, we have membership into that, and our representatives in that task team has been working closely with the Secretariat plus the experts that have been engaged towards undertaking the JBS-2.
The field sampling component of JBS-2 will provide the second comprehensive assessment of the chemical, physical and ecological condition of the Orange-Senqu River Basin. JBS-2 will draw on the lessons learnt from JBS-1, from the expertise of personnel participating from member states, as well as the involvement of members of the International Commission for the Protection of the Danube River and German-based GIZ.
GIZ is the Deutsche Gesellschaft für internationale Zusammenarbeit. You could translate it in the Organization of International Cooperation. It's based in Germany. It's projects on all sorts of different topics, be it natural resources, rural development, agriculture, health, and so on. We are working on water issues. We're in the Water and Environment Department, so we're working on transboundary water management in the SADC region, Southern African region. We are commissioned by the German Ministry and the Australian and British Ministry, in this case, for this transboundary program.
Several key river health and water resource quality components were focused on in the first survey. Aquatic ecosystem health, AEH, persistent organic pollutants, or POPs, chemical and microbial water quality, interlaboratory benchmarking, and public and schools events, which covers all stakeholders' participation. These components will once again be the focus during the second survey. JBS-2 also affords the opportunity to draw comparisons between survey results of 5 years ago during JBS-1.
The way in which we look at our river systems is using ecostatus methods here in South Africa. So we have a range of ecostatus tools. These ecostatus tools use a scale of A to, I think it's F, where F is a critically modified system and A is a pristine or natural conditions. Many of the sites actually fell into a C category, and only a few, probably about 2 or 3 of the sites actually fell into a B category. And then there were a few that fell into the D category. The majority of the sites that they sampled were sitting, or that they reported on, were sitting in a C category.
On the 20th of July 2015, the survey teams meet near the confluence of the Vaal and Orange Rivers in the town of Douglas in the Northern Cape province. The teams participated in a pre-sampling coordination workshop and tested all the sampling methods on site at the Orange River. This was to standardize sampling protocols, check equipment, and finalize logistics. The following day, teams conducted sampling at 2 sites independent of each other, located near Douglas in the Vaal system, after which they returned to their base to discuss any problems they may have encountered regarding the short test survey. The objective of this process was to standardize sampling protocols and procedures, eliminate technical issues, and share information.
It's gone well. Access has been a bit of an issue, trying to find sites, getting hold of farmers and so on, getting down to the rivers. That's been problematic in some areas. Finding the sites, particularly sites that haven't been sampled before.
Monitoring during the second joint basin survey will be performed by 3 teams, each comprising of experts and non-key experts that are competent and capable of sampling the different aquatic ecosystem health components. The 3 teams will be split to cover the 1 million square kilometre basin. Team 1 will focus on sampling sites situated along the upper Orange River, extending east from Douglas to the Lesotho Highlands.
My role is project leader on the whole project, so coordinating all the 3 teams, but physically on this particular trip also looking after the upper Orange system, which goes up into Lesotho, Senqu River system, and yeah, coordinating that team.
Team 2 will concentrate on sampling sites situated along the Vaal River and its major tributaries extending northeast from Douglas to Klip River.
I'm the team leader for the Vaal River team. I'm the aquatic macroinvertebrate specialist on the team. We've got 14 sites to sample throughout the Vaal River catchment. Some of them are in the main stem of the Vaal, and other sites are in tributaries, major tributaries of the Vaal River catchment.
Team 3 will focus on sites situated along the lower reaches of the Orange River and its major tributaries extending west from Douglas to the Fish River, Namibia.
I'm the team leader of the Lower Orange team, or the Lower Orange survey team, and we're going to give it a go and see, apply the tools that we've been applying across the country during different surveys. So we're sampling fish, macroinvertebrates, vegetation as well, indicators of environmental well-being, and we use tools, a certain range of tools that we apply in the environment or in the rivers to give us some indication of how well the fish communities are doing, how well the invertebrate communities are doing, vegetation communities are doing, and that gives us some idea of what the threats are like, or the pressures are like from environmental or external impacts on the well-being of our rivers.
The survey will take the teams to some of the most breathtakingly beautiful parts of southern Africa. JBS2 is supported by an interlaboratory benchmarking process. This is designed to help laboratories in all countries establish quality control procedures and to compare their data. The interlaboratory benchmarking will occur simultaneously with field sampling.
The interlaboratory benchmarking exercise as part of the Joint Basin Initiative is to try to get increased capacity across the basin within the laboratories. So the idea here is that we're collecting samples at a number of key sites within the basin. Those samples will be taken to a central place. Those have been then distributed to each of the laboratories in each of the member states, and each of those laboratories then will analyze that water for whatever their capacity is to do those analyses. And it's really an opportunity for the different laboratories, the different member states, to actually now compare and see how they're doing against each other.
The ORASECOM Secretariat provided a list of 56 potential sampling sites for the survey. Of these sites, 16 were sampled as part of JBS1 and therefore form a core selection of sites that should be sampled as a minimum during JBS2.
In this survey in JBS2, we're sitting with the same list of 56 sites, but we are attempting to monitor and actually go and sample as many of those sites as possible. Currently we have 41 sites on our list that will be sampled as AEH sites. We then have 6 groundwater sites that will be included.
So the groundwater is primarily accessed through boreholes. Some groundwater might be accessed through springs and ephemeral rivers. So the importance of groundwater in this region is that in the upper catchments of the Orange, the Vaal and the Senqu rivers, those are high rainfall, high summer rainfall areas where you're getting in excess of 1,000 millimeters a year in some areas. And down here in the lower Orange, the Malopo and Noso Basin areas, the rainfall is highly variable and between 100 and 500 millimeters per year. So there's a high reliance on groundwater resources.
Another crucial element of the survey is assessing the health of aquatic ecosystems.
One of the major functions of ecosystems are things like they assimilate our waste, that we release our waste into these environments and the river actually eats it up. The river, all the organisms inside it actually take all that waste out of the water. So that's a service that we get from the ecosystem. And what do? We need to make sure that we are able to maintain those ecosystem services, that those services are sustainable, and as well that we want to be able to protect those organisms, those things that live within those ecosystems. So in order to ensure that we can do that, we need to balance what we refer to as the use and the protection of these ecosystems. And the only way that we can ensure that we're doing it is if we monitor them.
Specialists shall use the SAS system to look at the diversity of fish life as well as the diversity of smaller organisms, insects, snails, worms, diatoms, and others present in the different habitats at the sampling site.
SAS stands for the South African Scoring System. The way it works is that each of the different taxa or families of organisms in the site have got different tolerances to disturbance. So what we do is we go out, we collect a representative sample of the aquatic macroinvertebrates at a site using a standardized protocol. We then bring that sample, put it into a tray, and for 15 minutes I go through it and see how many different aquatic macroinvertebrate taxa I get. Those get noted on a data sheet, on a score sheet essentially, and at the end of the day what I can do is I can add up the scores for all the different taxa that I found at the site, add them all up, and that'll give me a score for the site based on the aquatic macroinvertebrates at this particular site.
The aquatic ecosystem also includes assessments of the riverine habitats and riparian vegetation.
Vegetation tells you a story as you're walking around. It will tell you how much disturbance is actually present in the system currently. So what we're trying to do is having a look at what do you think the conditions would be if there wasn't things like dams and irrigation schemes and interbasin transfers upstream.
You've got all these trees on the side here, lovely poplars, so it looks really lovely, and you'd think the site's really good from a riparian vegetation point of view, but sadly it's not. These are all alien plants, so they've come from outside of South Africa and they've established here on these riverbanks, and what you see now is below these trees there's nothing growing, nothing holding the bank together, and in a big flood the whole bank just sort of collapses into the stream. So we can see this is a perfect site to show just the impact that alien plants have on these riparian zones.
Persistent organic pollutants, or POPs, are substances such as the pesticide DDT that persists for long periods in soil, sediment, plants, and animals.
There's a wide variety of different POPs. We often refer to a lot of them as endocrine disrupting compounds. So there are a lot of chemical processes and or fertilizers and pesticides that people use to target pests on crops. And because they're persistent, that means that they break down very slowly in the environment, that they're often active and available in the ecosystem for extended periods of time. So you may be spraying a pesticide onto a particular crop here, and that pesticide is persistent for a long period of time. It may leach into the rivers and cause an impact on the river for many, many kilometers.
During JBS2, a separate study was initiated to survey POPs and heavy metals at selected sites within the basin. The results of the POP study will feed into and be consolidated with the outcomes of the JBS2 to collectively inform the state of water resources quality of the Orange Senqu River Basin in 2015. The team of specialists make use of state-of-the-art technology to assist with the monitoring of water quality.
This is a multi-parameter water quality monitoring probe, so it's got a different little probes inside that tube there that read temperature, dissolved oxygen, pH, and a whole lot of other parameters, electrical conductivity. And what it does is it Bluetooth just to this app on the phone, and we're able to record the water quality over time, which is quite nice. And then we can just email these results to ourselves with GPS coordinates and the site photo, and we've got all of that together then.
Some of the equipment used is more basic but extremely functional.
This is a clarity tube. What it does is it measures how clear the water is. So there's a formula where you can use to change the centimeters that come down the side of the tube, and you convert that into turbidity units. So it's an idea of how clear the water is. Because if you think about it, just like we've got grass on land, in the water you've got algae, and they need sunlight to grow. So the dirtier the water is, the less sun is able to get through, so the less algae is able to grow. So the less macroinvertebrates you have, so the less fish. So it's all part of the food chain.
One of the ways in which the teams gathered information at the sites was to chat to locals who were impacted by the river that flowed through their part of the country.
Op hierdie stadium soos ons nou wat hier teenoor moet ons 'n paar bokketjies bly. Ons drink hom maar so skoon soos uit die water uit, soos nou daar is. En ons nog 'n snaaks gevoel op klagte opgedoen of so. Ek meen ek weet nog nie in die toekoms nie, maar sover. Wat stroom ook gebeur, mense dink nogal so 'n bietjie daaraan aangesien jy mos die water nou net so gebruik. As jy nogal so 'n bietjie, as jy hoor van 'n ding daar bo rond, dan raak jy nogal bekommerd. Want jy gebruik hom as maar net so en jou diere gebruik hom as net so.
Voor die damme gebou is, was die vloei van die rivier baie anderster as wat dit nou is. In die winter was die rivier tradisioneel laag en die water was silwer skoon. En in die somertye wanneer dit gereën het, was die rivier voller en dit was meer modderig geweest. So dit is die groot verskil wat nou gebeur het nadat die damme gebou is.
Perhaps the most exciting and rewarding parts of the JBS are the 5 public events held throughout the basin.
In terms of the involvement of school children, we are taking them as future champions of the management of water resources as well as its development. We all know that these are our future leaders, these are our future politicians, so we believe that making an input towards their knowledge as well as education and awareness on the issues related to river health will make a contribution to the way that the river system will be managed in the future.
Schools were given the challenge of compiling a presentation on the conservation and preservation of the Orange Senqu River Basin. In each country, the nervous youngsters presented their efforts to a panel of judges.
Let me read you a piece of a paper about water.
The winners from each country were announced during the public events.
It's Rospina Academy.
Mutati Primary School!
The aim of these events is to raise public awareness of ORASECOM as well as the work being done in the survey. Local schools were shown how to apply simple methods to assess the health of the aquatic ecosystem, and the students taught how to apply the simplified mini-SAS developed in South Africa to make an assessment of the health of the river. During JBS 1, the results of these assessments were included as part of the detailed report on the event. The second survey shall also include the input from the young scholars of the basin. During JBS 2, as with the last survey, there were many unplanned benefits. The impact on youngsters that attended practical sessions on the banks of the basin's rivers was immeasurable.
Some days we will have no water in South Africa, and there will be no world, because water means life. Without water, we are nothing.
It is important to conserve the water so that we can get water to drink and for our livestock and farming and mining.
Water is life. It's going to save us.
It is through programs like the Joint Basin Survey that an awareness will be created amongst all who work and reside in this shared river system. An awareness that will hopefully spread through the nearly 1 million square kilometers of this complex bowl of life and leap from generation to generation.